Okay, so today we're going to be talking about operations with radical expressions. So now that we know how to simplify radical expressions, we're going to move on to doing certain operations with them. We talked a little bit about multiplying in the last section, but we will come back to multiplying again, probably tomorrow. But at least for today, we're going to focus on what happens when we add or subtract radical expressions. So if we think back to when we added or subtracted any other regular expression, something like if I wanted to do 4a plus 2a, it was very simple. We said as long as it had the same variable, I could just take the coefficients and I could add those together and just use the variable at the end of this. So this would actually become whatever 4 plus 2, which is 6a. All right. And then the same thing would go with subtraction. If I had something like 9b minus 2b, we would just work, again, because the variables were the same, I would look at just the coefficients, and I would do 9 minus 2 and keep the variable the same as b. So again, 9 minus 2 would be 7, and this would just end up being 7b. So the same thing that we did here with our variables happens with our radicals as well. So when I have a radical expression of something like 4 radical 5 plus 2 radical 5, it goes along the same idea of this. Seeing how my a was the same, we only worked with the coefficients and we added them together here. The same thing is going to happen with this. I'm going to take my coefficients, I'm going to add them together, but the radical is going to stay exactly the same. So here I'm going to have 4 plus 2, but I'm going to keep the radical 5 exactly the same. I'm not going to change it, just like we didn't change it with our variables, right? We had 4a, 2a, we just kept the a on the end here. Same with the radicals. Radical 5, we're going to have the radical 5 at the end here. So this is going to end up being 6 radical 5. Notice how we do not add what's underneath the radicals. We do not add the radicands together. Just like we didn't add the a's together, we just had an a here. The same thing would happen with subtraction. If I had something like 9 square root of 3 minus 2 square root of 3, because my square roots are, again, exactly the same, I just want to take the coefficients and do whatever operation we have here. So this is going to end up being 9 minus 2, and then just add or put or multiply the radical 3 at the end. So this is going to end up being 7 radical 3. Notice here that when we add or subtract our radical expressions, the radicand does not change. It's the exact same with our monomials here. When we added variables, the variable didn't change. When we add radicals, the radicand does not change. So let's do a couple practice problems here with this. So let's say I wanted to simplify the expression 5 radical 2 plus 7 radical 2 minus 6 radical 2. Okay, so if I'm working with this, again, we know that we can combine anything that has the same radicals together. So here, if we look, we have a radical 2 here, a radical 2 here, and a radical 2 here. So all of these terms I am able to combine. So like we said in the previous slide, what I can do is I can take my coefficients and do what the operation says. So this can actually become 5 plus 7 minus 6. 5 plus 7 minus 6. And since they all share the same radical, that radical is getting multiplied by those coefficients. So all I have to do is simplify what is inside here. So 5 plus 7 minus 6, this is going to be 12, minus 6 becomes 6. So this is going to end up equaling 6 radical 2. This would be my final answer. All right, let's try one more. Let's say I had 10 radical 7 plus 5 radical 11 plus 4 radical 7 minus 6 radical 11. So here, unlike the other ones, all of my radicals are not the same. So remember, you can only combine radicals that share the same radicand. So here, if I look, this radical 7 and this radical 7, I can combine these two terms together. Same for my radical 11s. I can combine these two terms together. So when I do that, I have to just make sure that I separate those. So for these, because they have the same radical, I'm going to take the coefficients and put those together. So it's going to be 10 plus 4. And then on the outside goes the radical 7. Then I'm going to add the 5 minus 6 here. So this is going to be plus 5 minus 6. And they share the same radical of radical 11. So that goes on the outside. So now I just have to combine these terms here. 10 plus 4. That gives me 14 radical 7. Now 5 minus 6, this is going to give me a negative 1, but we know that we never have plus and negative, as we said all the time in class. So we don't put plus negative 1, we will just put minus 1. Now again, we don't have to put the coefficient of 1 here. If you have a coefficient of 1, it does not have to be there. So we would just put minus, because it is a negative 1, square root of 11. And then this would be my final answer. Because again, I can't combine these two terms because they don't have the same radicals. This is a radical of 7 or a radicand of 7. This is a radicand of 11. They're not the same, so I cannot combine them. So here I'm giving you 4 different problems. I'd like to see you try and do some of these on your own. So pause the video here, take about 5 minutes, and try and solve these on your own. Or I shouldn't say solve, I should say simplify these on your own. All right? So pause the video here, take a couple minutes, practice these. When you unpause, the answers will be here. So here are the 4 answers. If we quickly look at each of these here, for the first one here, we see that they all have the same radicand of 2. So I'm just going to be working with the coefficients, and I'm going to be combining all of those. So it's going to be 3 minus 5, which is negative 2, plus 4, which is 2. So it's going to be 2 radical 2. For this one here, same thing. I have the same radicand of 11 in all 3 of them. So I'm going to work with my coefficients, combine each of those. 6 plus 2 is 8. Minus 9 gives me a negative 1, but like we said before, I do not have to put the negative 1, so it's going to be negative square root of 11. For this one has a radicand of 3, as does this term here, so I'm only going to be combining these two terms. So I'm going to combine my two coefficients, 15 minus 11, that's going to give me 4 radical of 3. For these, we have the radicand of 5, so I'm going to be working with combining these two coefficients together. Negative 14 plus 6 gives me negative 8, so it's going to be minus 8 radical 5. Same thing down here. This has a radicand of 3. This has a radicand of 3. So I'm going to take my two coefficients, combine those together. 4 minus 6 gives me negative 2 radical 3, and then this has a radicand of 7 and a radicand of 7, so I'm going to combine those together. 3 plus 3 gives me 6 radical 7. So the problems we had previously done, all of the radicands had been identical or at least had some sort of a pair that we could have combined them with. But that's not always going to be the case. We could end up with something where we have 2 radical 18 plus 2 radical 32 plus radical 72. So if we look at this problem here, this one I see that none of my radicands are the same. So your initial thought would say, well, I can't add any of them together because none of them are the same. But the problem with that is that each of these radicals may not be completely simplified. Like we talked about in the last section, we can simplify radicals. And whenever we're looking to add or subtract radicals, we have to make sure that we have the radical completely simplified first. So what I need to do with each of these radicals is I need to simplify them first. So I'm going to look to simplify 2 radical 18 first. If we remember back to last video, to simplify a radical, all we have to do, we take our radical and we look to find its greatest perfect square. So again, our perfect squares are 1, 4, 9, 16, 25, 36, and 49, 64, and 81. And we'll stop there for this problem because, again, if we look at each of my radicals, the highest number is 72, so I can stop at 81. So for 18, and I am going to bring this 2 down here as well, just so that we don't forget it. But for the radical 18, I'm going to start here at 16, and I'm going to look at every number lower than it, and I'm going to divide each of these by 18, and see which one of them is a factor, or the highest perfect square factor of 18. Well, 16 divided by 18, 18 divided by 16, that doesn't work, but 9 does. That means that 18 can get split up into the square root of 9 times 2, because again, 9 times 2 is 18. Don't forget about this 2 that we have in front here. So now I can split my square root up into the square root of 9 and the square root of 2. And now the square root of 9, as we know, is just 3, so this becomes 2 times 3 square root of 2, or 2 times 3 is 6 square root of 2. So we see how now we don't have a radical 18 anymore. Now we have a radical 2. Now it still doesn't match these, but we haven't gone and simplified each of these problems either. So we have to go do that as well. So I'm going to now work with 2 radical 32. And I'm going to look to simplify that. So working with 2 radical 32, again, I'm going to work with all of my numbers from right here and down. And I'm going to take 32 and I'm going to divide them by each of these numbers to figure out which one is the greatest perfect square. So I start with 25, that one doesn't work, but 16 does work. So if I take 32 and I divide it by 16, I'm going to get 16 times 2. So again, this splits up into square root of 16 times the square root of 2. And we know that the square root of 16 is just 4. And then 2 times 4 gives me 8 square root of 2. Now, one of the biggest things that people will forget at this point is they forget about this sign here. Don't forget to bring that sign all the way down, because we are still working at the end here to look to simplify. So I need to keep my signs in order. So this sign is going to be brought down. So now, without simplifying this last one, which we'll do in a second, now I have 6 radical 2 plus 8 radical 2. It looks different than up here, but numerically, these are both the exact same. We've just made them look a little different. So now let's work with the square root of 72. So I'm going to take that and I'm going to do the same thing. I'm going to simplify the square root of 72. So 72 is right here in my numbers, so I'm going to work with every number less than 72. That's a perfect square. and I'm going to see which one is the greatest perfect square. So I go through my list. 64 doesn't work, 49 doesn't work, but 36 does. So 72 is now going to split itself up into 36 times 2. Because again, 36 times 2 is 72. Which then this becomes the square root of 36 times the square root of 2. And the square root of 36 we know is just 6. So this is simplified down to 6 radical 2. Again, I don't want to forget about this sign, so I just bring it all the way down here. And now I have a new simplified addition problem of 6 radical 2 plus 8 radical 2 plus 6 radical 2. And now I can say, well, all of my radicals are exactly the same, so that means I can take my coefficients and I can combine them. So this is actually going to become 6 plus 8 plus 6, and that's 8. It's a little bad. Still working with the mouse here. I should be getting a stylus soon. Radical 2. And 6 plus 8 plus 6 will give me 20 radical 2. So my final answer here would be 20 radical 2. Okay, so let's try one more of these, again, just to make sure that we are understanding exactly what is going on here. So let's take this problem here, square root of 24 minus the square root of 54 plus the square root of 96. So again, we look at them initially and we see that none of my radicands are the same, so I can't combine any of them. But we know that these could possibly be simplified. So we're going to start with the square root of 24, and we're going to look to simplify that first. So again, let's write out our perfect square list. And again, we can stop there because our highest number is 96. So we'll work with the square root of 24 first. So where 24 is right here. So we are going to be looking for the greatest perfect square that is a factor of 24. So when looking at that, we're going to start by dividing by 16. So 24 divided by 16. Nope, that doesn't work. 24 divided by 9 does not work. But 24 divided by 4, that one does work. So this is going to split up into the square root of 4 times 6. So again, this we can rewrite as the square root of 4 times the square root of 6. And the square root of 4, because that's a perfect square, we know that that is 2. So this becomes 2 square root of 6. Don't forget, take your sign. Just drop it all the way down. So this is going to be minus. Now we're going to simplify the next one, square root of 54. I'm going to do that over here just so we have a little bit more room. So the square root of 54. So again, 54 falls right here. So I'm going to take 54 and I'm going to divide it by all of my numbers. And when I do that, we're going to have 49 doesn't work, 36 doesn't work, 25 doesn't work, 16 doesn't work, but 9 does work. So 54 can get split up into 9 times 6. And again, this can be rewritten as the square root of 9 times the square root of 6. And the square root of 9 is just 3, so we are left with 3 square root of 6. So I'm just going to move this right over here since we started our problem here. So this is going to be 3 square root of 6. Again, don't forget, bring your sign all the way down. So plus, and I'm going to do the same thing with the square root of 96. Going to look to simplify the square root of 96. So 96 falls right here. So I'm going to take 96 and divide it by all of my perfect squares to see which one is the greatest one. 96 divided by 81 does not work. 96 divided by 64 does not work. Divided by 49 does not work. Divided by 36 still doesn't work. Divided by 25, nope. Divided by 16, that one works. So 16 works, which means I can take the square root of 96 and split it up into the square root of 16 times 6. Because again, 16 times 6 is 96. So this can be replaced or rewritten as the square root of 16 times the square root of 6. And the square root of 16 we know is 4. So I now have 4 square root of 6. And as we see now, all of my radicals again are exactly the same. So I'm going to take my coefficients, I'm going to combine those, so 2 minus 3, because again we have to worry about this sign, is -1, plus 4 is going to give me 3, and then the square root of 6. So my final answer would be 3 square root of 6. So again, I've given you 3 problems that you can do some practice work on. I suggest pausing the video, trying to do these 3 problems on your own, and then unpausing it to see if you've gotten the answers correct. Now on the side of the page here, I've even given you all of your perfect squares that you will need for this one. I even went past the 196 that I normally go to help you out with that last one where you have the square root of 245. So again, pause the video here, try and do a couple practice problems, and then unpause it to see if you've gotten them correct. So as we see here, we have our answers. For the first one, we would get 16 square root of 6. For this one here, we would have -16 square root of 3. And for the last one, we would have 4 square root of 5. Hopefully you got those. If not, go back, check to see if maybe you didn't simplify these correctly. Remember, when simplifying, you take the number, look for where it falls on the list. So like in this case, 54 falls right here. And you would look to find the greatest perfect square. So you'd start by doing 54 divided by 49, then 36, then 25, 16, 9, 4, 1. Whichever one is the greatest one that works with it, you would split it up, rewrite it, and then you would simplify from there.